You are watching the 3.5 lesson video on graphing linear inequalities. So, in the past, we have graphed lots of lines. We've manipulated the equation to get y alone, and we've typically just graphed in slope-intercept form, which is something we are actually going to do in today's lesson. The only thing that's different is that we are going to be graphing inequalities. So because of that symbol, so either the greater than or equal to, less than or equal to, greater than or less than symbol, we have a couple differences. So sometimes we might have some shading either above the line or below the line. Our lines can either be dashed or solid, and these are all things that we're going to pay attention to when we're graphing, and that inequality symbol is going to tell us that information. All right, so moving on to questions 1, 2, and 3, we need to transform each sentence into one where the left side is only y. Basically, it means get y alone. So number 1, y is not quite alone yet because this minus 2x is being taken away, or the 2x is being taken away. So let's just move it to the other side. I'm just going to use my sorting. The y stays the same. My less than symbol stays the same. The 2x had to be moved over, and it became positive because it switched sides. So this becomes 2x plus 3. That's it. Okay, let's sort in number 2. I'm going to put my y's on my left side because that's what the directions said, and no y's over on the right side. So the 3x, all right, well, first off, let's drop down that inequality symbol, the greater than or equal to. The 3x has got to go and become negative. The y has got to go and become negative. And the plus 4, he's all right. Bring him down. All right, now it's actually a negative 1 in front of my y. So what I'm going to do is divide every single term by negative 1 because I need y alone. But remember, when solving inequalities, if I divide by a negative, the same rule applies even for inequalities with 2 variables. And what am I talking about? Well, I need to flip my inequality symbol and change it to the other direction. So y is now less than or equal to 3x minus 4. Okay, moving on to question 3. I'm going to leave the y's on the left side and the no y's on the right. So the negative 4y is in the right place, is greater than, well, the 3x has got to go. And since it's negative over here, positive over there, and the plus 12 just stays the same. Looks like we need to divide everything by a negative 4 this time, and you got it. That inequality sign needs to change direction again because we divided by a negative. Now, if this had been a positive 4, we wouldn't have had to do any of this, or we wouldn't have had to have changed the inequality sign, I should say. So instead of a greater than symbol, we now have a less than symbol. So y is less than negative 3/4 x minus 3. Okay, now for the fun stuff. Let's start graphing these. So we are actually going to graph this exactly how we would graph a line. So if this were y equals 1/2 x plus 3, we would start at the y-intercept of 3. Then we'd go up 1 to the right 2. And we would do this to cover the whole graph. So let's just go through that whole process. I could go down 1, to the left 2, keep at it, plot, 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 plot. Okay, now the only difference is with an inequality we have to worry about whether or not the line is solid or dashed, and if we are going to shade above or below. So in number 4, since it's not equal to, I don't have that underline here, we are going to have a dashed line because it's not equal. Okay, we're in question number 5. I think we're probably going to have a solid line because it does have that less than or equal to symbol. Okay, so let's graph a dashed line. And of course, we are going to put arrows on both ends. For some reason, this only puts an arrow on one end, but we'll put it on both. And we now need to either shade above or below the line. Well, since this is a greater than symbol, that means we will shade above. And let's write greater. So it's important to know the difference. Remember, if you make L's with your hands, the L makes the lesson if you ever get confused. So I like to show my shading like this, almost like perpendicular to the line, because it's easy to see. And then, of course, the last and final step, label with the original inequality. And we're done. Okay, let's go ahead on to number 5. Remember, we graph an inequality the same way we graph an equation. So we start at the y-intercept of -5, and it looks like my line here has a slope of 3 over 1. So up 3 to the right 1. And do this to cover the whole graph. Even downward. Okay. Now, we need to figure out if the line is solid or dashed. If it's solid, it means it can be a solution. So we're going to have a less than or equal to, or a greater than or equal to. And we actually do, because it can equal. So we will have a solid line. And don't forget your arrows on the ends. Okay, now we need to worry about shading. Is y smaller than or bigger than? Well, y is less than, so this means we actually need to shade below. Now, if you ever get stuck on what's above versus below, sometimes I like to think of it as a roof, and I make it, I don't know, like a triangular roof and shade either under the roof or above the roof. But this is all below. Now, what does this mean? Oh, hang on. Let's label before I get talking. All right, y is less than or equal to 3x minus 5. Okay, so what this means is that all of the points up here in example number 4 are solutions. So I could plug in any one of these points up here into this inequality, and it would make a true statement. I would get something like 10 is bigger than 4, or 30 is bigger than 7. None of the points on this line are going to work because it's dashed, because it cannot equal. On the flip side, in number 5, all of these points would work, and every single point on the line would work too. And what do I mean by will it work? Well, if I pick any point, so if I picked the point, let's say 2, 1 right here, and I substituted it in and simplified, it would balance and it would make a true statement in the end. We'll talk more about that shortly. Okay, moving on to question number 6, you can see right now that this isn't very easy to graph, just like it wouldn't be easy to graph if this had been an equation, because y is not alone. So let's bring the 3x over to the other side. So y is bigger than negative 3x plus 1. Ah, this is so much better. Okay, so plot your y-intercept, and since my slope is negative 3 over 1, I know I'm going to have a downward slope, so down 3 to the right 1. And again, cover the whole graph. Okay. Now, they haven't guided us with anything yet, so we need to use our newly created inequality to help us. Can this be equal to? No. So not equal. So this means we have a dashed line. So let's pull out the dashed line. And when I make a dashed line, I use a ruler, and I just kind of dash it as I go. But using a straight edge is really important. So I'm hoping that you are using a straight edge. Okay. Now we need to figure out, what do we need to do? We have to shade. So is y bigger than or less than? So since it's larger than, greater than, we are going to shade above this line. Okay? I know a lot of you are saying, hey, go ahead and label. We can label this with the original or the new. They're both equivalent inequalities. And there's a little bit down here that we have to give. So it says give two solutions. So this is what I was talking about on the other two questions. We need to pick any 2 points that are in the solution. So, let me use the red color here. So any point in the shaded area. Let's say the point 3, 4. 3, 4 is a solution. How about the point 7, -2? I mean, there's so many of them that we could use. Let's talk about things that are not solutions. Well, obviously something over here is not going to work. So let's say -7, +3. And how about, let's pick a point on the line because it's a dashed line. So the point -1, what did I fill in? -1, 4 will not work because it is on the line. Okay, here we go with number 8. So number 8 says y is always smaller than -3. All right, well, let's first find where y is equal to -3. So here's my y-axis. Here's -3. What kind of a line is it going to be? Can it be equal to y? And the answer is no way. So dashed line, here we come. Arrows on both ends. I'm going to label it now so I don't forget. And, it looks like y is smaller than -3, so that indicates to me all of these points below are going to be solutions. That kind of helps me with this next part. 2 solutions, let's pick, oh, I don't know, 1, -9. That's a solution. How about -5, -4? That's another solution. Oh, -4. Okay, non-solutions would be any points on the graph. How about the point, well, let's do the y-intercept. 0, -3 wouldn't work because it's on the dashed line, and obviously any point that's not in the shaded area. So let's just pick 10, 10. All right, moving up to, let's go ahead and do 9. Did I skip one? Sure did. Okay, we'll go back and do 7 in a minute. Let's do 9 next. So 9 says x is bigger than or equal to 5. So let's find where x is 5. That's this axis right here. And x can be equal to. So you got it. We are going to fill in that line. This is not dashed. It can equal. All of those points on that line are solutions. There's my arrows. There's my label. And how are we going to shade if x is always bigger than 5? Well, all of these numbers over here are bigger than 5. So this is where the graph will be shaded. If we want to start picking solutions, we can pick points that are actually on the line now, like the point 5, 6. That would work. And any point in the shaded area. So let's say 9, what is that, 9, -2. Okay. Non-solutions. Hey, the origin's not working, so let's put that in there. 0, 0. That's a fun one. And how about -6, +3? Because that is not in the shaded area. Okay, last one. Back up to question number 7, which I skipped. All right, number 7 says twice x. All right, looks like we have some translating to do. So twice x less triple y, less triple y is more than, oh, there's our greater than symbol, 27. Oh boy, looks like we need to do some sorting. Not a problem. The -3y is where I want it to be, but this 2x has got to go and become negative. And then the 27's all right. Next step of the way, let's divide to get rid of that -3. But wait a minute, we are dividing by a negative. So what happens to our inequality sign? That's right. Okay, you're going to flip that inequality sign. So y is less than 2/3 x minus 9. Let's start graphing. So our y-intercept is -9, and our slope is 2/3, which means up to the right 3. Let's cover our whole graph. It looks like it's just in this bottom section. Okay, since it cannot equal, we have a dashed line. Of course, we're going to put arrows on this, and we can label it either with the original or the new. Let's go with the original. No fractions. 2x minus 3y is bigger than 27. Okay, so how will we shade? Above or below? Well, y is less than 2/3, so below this line. Let's give two solutions. So anything in the shaded region? Let's go here. 10, -10. And, oh, I don't know. How about this one? 2, is that -9? 2, -9 is a solution. Looks like we can use the origin again. 0, 0, and let's just pick a random one up here. 3, 1.